Two chips are about to decide who controls AI in 2026. One costs a fortune and powers almost everything you touch. The other hides inside Google's walls, quietly answering billions of questions a second. NVIDIA's Vera Rubin against Google's TPU V8. And the winner isn't who you think. Here's the number that started the war. Rubin pushes 50 petaflops of NVFP4 inference per chip. That's not a small bump over Blackwell. It's a leap. Bolt on 288 gigabytes of HBM4 memory, screaming at 22 terabytes per second, and you get a chip built to swallow the biggest models alive. But hold that thought, because Google didn't build one chip to fight back. They built two. And one of them was made for a single purpose that puts Rubin in real danger. I'll show you which one in a second. First, why Rubin feels unstoppable. It's not just the silicon, it's the whole rack. The Vera Rubin NVL72 links 72 GPUs into one giant brain, with NVLink moving 3.6 terabytes per second between them. No bottleneck, no waiting. The model just flows. Then there's the part nobody can copy fast, CUDA. Every tool, every framework, every engineer already speaks NVIDIA's language. You drop a model on Rubin, and it just runs. That lock-in is worth billions, and Google knows it. So Google attacked the one place NVIDIA bleeds, price. Meet TPU V8. Google split it in two. The 8, T for training. The 8, I built only for inference. And that little I is the whole story. The 8, I delivers up to 12.6 petaflops of 4-bit compute, packs 288 gigabytes of HBM, and talks to other chips at 19.2 terabits per second. But the real weapon is scale. You can chain over 1,100 of these into a single pod, acting as one machine. Here's the secret I promised. Google doesn't sell these chips, they rent them. That means no markup, no middleman, no NVIDIA tax. When you serve 1 trillion tokens a month, that difference isn't small. It's the entire business. Now let's talk about the thing that actually pays the bills. Cost per token. Every word these models spit out has a price. A fraction of a cent. Tiny. Until you multiply it by billions of requests a day. Then those fractions become the difference between profit and bleeding cash. Rubin is faster per chip, no argument. But fast isn't free. You buy the GPU, you pay the NVIDIA margin, you pay the power bill, and HBM4 running at full tilt drinks electricity like a furnace. For frontier models, you pay it gladly. For serving the same chatbot 1 million times an hour, that price starts to hurt. Now flip to latency. The 8i was tuned for one thing only: answering fast, cheap, and at insane volume. No training baggage, no wasted silicon. Just inference, stripped to the bone. And remember that secret about renting? Watch what it does to the numbers. When Google controls the chip, the data center, and the model, they shave cost at every single layer. Nobody buying off the shelf can match that stack. So who actually wins? Depends on one question. What are you optimizing for? If you need raw flexibility, Rubin wins clean. Any model, any framework. Day one. The ecosystem catches you when things break. For startups moving fast and labs chasing the frontier, that safety net is everything. But if you're running inference at hyperscale, the math flips hard. TPU V8i squeezes more answers out of every watt and every dollar. At Google scale, fractions of a cent per token turn into hundreds of millions saved. That's why Gemini runs on TPUs, not on someone else's chip. And here's the twist most people miss. They're not really fighting for the same customer. Rubin wins the open market, the thousands of companies who need a chip that runs anything they throw at it. TPU V8 wins the closed kingdom, the handful of giants serving models to the whole planet who can afford to build around silicon nobody else can buy. So the honest verdict, there is no single winner. Rubin wins on power and freedom. TPU V8 wins on cost and control. One rules the world's GPU racks. The other quietly runs the searches and answers you already use every day. The real lesson? In 2026, the question stopped being which chip is fastest. It became which chip is cheapest at scale. And that shift is rewriting who holds the power in AI. Watch the next move closely. NVIDIA wants into Google's territory with cheaper inference parts. Google wants to break free of NVIDIA for good. Both are building toward the other's strength. The chip that closes that gap first doesn't just win a benchmark, it wins the market. Pick performance, you reach for Rubin. Pick price at scale, you build on TPU. Everyone else is just choosing which giant to depend on. Thank you.